Welcome to our Let's Learn channel. Today we are going to see about electric potential and potential difference. In this case, we know generally that the flow of charges in a conducting metallic wire, the electrons move only if there is a difference of electric pressure, which is nothing but potential difference along the conductor. We know this definition. So here what we need means there should be a difference of electric pressure. In this case, this difference of potential may be produced by a battery consisting of one or more electric cells. When the cell is connected to a conducting circuit element, the potential difference sets the charges in a motion. We know very well that the charges sets to be in motion in the conductor and it's producing the electric current. Okay, now let's learn the electric potential difference definition, which is nothing but that the electric potential difference between 2 points in an electric circuit is the work done, which is nothing but first we are considering work done, and the next in a moving unit positive charge q from one point to another point. So the potential difference is nothing but work done by q, which is nothing but charge. So v is equal to w by q. The SI unit of potential difference is volt, because the potential difference we can say it is in a v, right? Okay, in this case we know very well that the SI unit of potential difference is volt. So now we can easily write that 1 volt is equal to, for work done we can say joule, divided by for charge we can say coulomb. So 1 volt is equal to 1 joule by 1 coulomb. Now let's learn the definition for 1 volt now, because we know the formula now, right? Okay, 1 volt is the potential difference between 2 points in a current carrying conductor, because we need a current carrying conductor. Otherwise, if you are using insulator, now there we can't expect a flow of charges. So that's what again we are telling about the conductor. So 2 point charge in a current carrying conductor when 1 joule of work done is to be done. Okay, so 1 joule of work done is done to move a charge of 1 coulomb from one point to another point. So charge moving from one point to another point, this is the basic, we should remember this. In this way we are just calculating the potential difference. And the next, now this is a schematic diagram which represents the symbols for conveniently we are using in a circuit diagrams. Okay, firstly about connecting lead. Okay, this is a cell, and this is the battery of cells. So battery cell means only positive and negative. In the case of battery, positive, negative, three batteries or two batteries we consider. Okay, which means this is a cell, and this is a combination of cells is nothing but we know very well battery. So one cell, and this is the two cells, but we no need to say this is a cell, this is a battery of cells. Okay, the next, this is a resistor, and this is the DC power supply. This is a positive and this is the negative part. We should consider with this end is positive and this end is negative, we have to consider. And next, junction of conductors. So cross the junction, across cross section we will learn in this case. And crossing conductors, no connection. Here in this case it's a small loop, we can observe this. So here in this case we can say there is no connection, crossing conductors. Okay, so filamental lamp, if you are considering a filament, means we can mention this symbol filamental lamp. So this is the old meter. We can just measure a volt in this case. And here it is ammeter. We can measure a current in this case. Okay, this is a switch. Whether it is open. Now it is open. If you close this in a single line, this is the closed switch. Now it is open switch. It is a variable resistor. We can vary the resistor by rotating the knob. Okay, this is the microphone symbol. Mostly we have used in communication oriented systems. Okay, this is a loudspeaker. Okay, the next, this is a light emitting diode, which is nothing but the LED. So positive diode and negative side we can consider in this case. So this is the lead. We will learn later in this case. Okay, fuse. If you are considering about the fuse now, we should use this symbol. And this is the earth. We know very well. When you draw a circuit diagram, we'll give a earth, right? So this is the earth. And this is the alternating signal, and it is a capacitor which it stores the current. Okay, this is a capacitor, and we should differentiate the cell and the capacitor. In this case it has it is a positive and it is this short line is negative, but this case both should be in a parallel, in an equivalent. Okay, so you should mention a difference between a cell or batteries and capacitors. And this is the inductor symbol, and this is a thermistor symbol. This is the thermistor symbol, and it is a light dependent resistor, LDR symbol it is. So in this case, LED and LDR is different. So we should analyze it differently, and we should draw whenever they ask LED, we should draw this like a diode. It have mentioned, and it is a resistor we should mention. Okay. So next. These are only different types of components we have just using cell and batteries symbols for cell, and this is for battery. And for electric switch, I've said it is a open and closed switch. So now it is open. If you close this knob through this, it is a closed switch. And this is a symbol. First one is open and second one is closed one. So this is the electric bulb we know. This is the symbol for electric bulb. Okay, next. Problem session. Now we learned a formula W is equal to V into Q. Yes? Okay. In the case V is equal to W by Q we have done. Okay, I need which means I have to work done. So here, how much work is done? They asked a question like this. So I need work done. So charges 5 coulomb they have given, potential difference they have given. They didn't give anything about work done, right? So now we should change the formula. V is equal to W by Q. Just take a Q from this end, from right to left. Now it will be W is equal to V into Q. We know what is V, which is nothing but 10, and we know what is Q, charge 5 coulomb, just put 5, and we know very well that W is equal to, now if you multiply this value, we'll easily get 50, right? So which is nothing but work done. So easily we can say that the unit is joule, right? So the problem session is very easy. We have to say whether how much the work is done. So in this case, they have given charge and potential difference. Through this, we can prove it. Okay, we should remember this formula because this is very basic. In this case, W is equal to V into Q, or V is equal to V by Q. Okay, this both are same. Whenever if you are finding V now, we will have a W and a Q. If you are going to find W now, we will have a Q and a V. So this is the basic situation in this case. So remember this always because this is very basic. Thank you for your attention. Kindly subscribe and like and share.